So here I've written some rules or properties for limits, and these are all assuming that f of x and g of x, the limit exists for all of them. So for the first one, the limit as x approaches a of c, if c is a constant like 10 or 3, then that's just c. So if you have like the limit as x approaches whatever value of 10 is just going to be 10. Next rule is the limit as x approaches a of a constant times a function, so like 10 times like x squared or whatever, then that's just the constant multiplied by the limit as x approaches a of that function. So the third rule is the limit as x approaches a of f of x plus or minus g of x, and this f of x and g of x, they're both included in the limit. It's not like the limit of f of x and then plus g of x, whatever. This is equal to the limit as x approaches a of f of x plus or minus the limit as x approaches a of g of x. So what you can do is just like separate these. You can just take this and then take the g of x and take the limit as of that, and then add or subtract them from each other. And here I've written two more rules, and the first one is the limit as x approaches a of f of x times g of x, and this f of x times g of x is both included in the limit. That is equal to the limit as x approaches a of f of x multiplied by the limit as x approaches a of g of x. And the second one is the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f of x divided by the limit as x approaches a of g of x. And this one only works if this part, the limit as x approaches a of g of x, is not 0, because, well, if it's 0, then you're dividing something by 0, which is not possible. And now let's do some examples. Starting with this first one that says the limit as x approaches 2 of 7. Well, 7 is a constant, and we learned that the limit as x approaches anything of a constant is just that constant, so this is just going to equal 7, because there's no place to plug in x to. And the second one, limit as x approaches 3 of 4x squared, we learned that if we have the limit of x approaches anything of a constant multiply a function, here we have the constant is 4 and the function is x squared, we can put this constant at the front of the limit, and we get 4 times the limit as x approaches 3 of x squared, and that is just 3 squared, which is 9, and we get 36. And now for this last one, the limit as x approaches 4 of 2x plus x over 4. All of this is included in the limit. I should have put parentheses. Well, we learned that if we have the limit as x approaches anything of one function plus another function, then we can like split this up into two limits. So first we have the limit as x approaches 4 of 2x, and you can just plug in 4 for x and you get 8, plus the limit as x approaches 4 of x over 4. That's just 4 over 4, which is 1, and you get 8 plus 1, which is equal to 9. Pretty easy. These properties of the limits are pretty intuitive, and we just solve these 3 problems using them. Now let's do some more examples. Here I've written the limit as x approaches 4 of 2x times the square root of x, and we learned that if we have something like this, we can separate the first function and the second function and evaluate the limits of both and multiply them together. So for this one, the first function would be 2x, second one would be square root of x, because that's what we're multiplying together. So it's going to be the limit as x approaches 4 of 2x, and that's just 8, multiplied by the limit as x approaches 4 of square root of x, which is 2. So we have 8 times 2, and that's just 16. And for the second one, I've written the limit as x approaches 2 of x squared over 4 minus x. And this is going to be equal to, well, we learned that if we have the limit of x approaches anything of a function divided by another function, we can split them up, just like we did for addition and multiplication. So first, the top, Well, the fraction is going to be the limit as x approaches 2 of x squared, which is going to be 4. And the denominator is going to be the limit as x approaches 2 of 4 minus x. And this is going to be 2. So you get 4 over 2, which is just 2. And yeah, for these problems, you could technically just plug in the x value using substitution. But for some problems, it will be easier to know all the rules and just apply them like this. Now, let's get into some practice problems. If you think you know how to do this one, then pause the video and do it. This problem says if the limit as x approaches a of f of x is equal to 4, and the limit as x approaches a of g of x is equal to 5, evaluate the limit as x approaches a of f of x, or the square root of f of x, times g of x cubed. So we learned the properties of limits, and we know that if we have something like this, we can separate these two limits, the f of x and g of x, because we're multiplying two things together. So the first limit that we're going to evaluate is the limit as x approaches a of the square root of f of x. And if the limit as x approaches a of f of x is equal to 4, then the square root of that is going to be 2. So the first one is 2, and then we multiply it by the limit as x approaches a of g of x cubed. And we can do this because we learned about it in the properties of limits. And if the limit as x approaches a of g of x is equal to 5, it's just going to be 5 cubed, which is 25. And our final answer is 50. Now, let's do another practice problem. If you think you know how to do this one, then pause the video and do it. This problem is pretty similar to the last one. It says if the limit as x approaches a of f of x is equal to 4, and the limit as x approaches a of g of x is equal to 5, evaluate the limit as x approaches a of f of x times g of x all over 3 times g of x. So the values for the limits of x approaches a of f of x and g of x are the same. They're 4 and 5 from the last problem. So first, for this problem, we notice that it's one of these divisions. So again, we can find the limit of the numerator and find the limit of the denominator and then divide them. So first, let's find the limit of the numerator as x approaches a. So it's f of x times g of x, and we know that if we have two functions multiplied together, we can find the limit of both and then multiply those limits together. And we're already given the limits, 4 and 5, and x is approaching the same value. So we have 4 times 5 is just 20 on the numerator. And for the denominator, we have 3 times g of x. And we learned that a constant multiplied by a function inside the limit, you can take out the constant and put it at the front of the limit. So it's just 3 multiplied the limit as x approaches a of g of x. And we already have it right here. It's just 5. So that's just 3 times 5. So it's 15. So we get 20 over 15, which can be simplified down to 4 over 3 as our final answer. So everything that I explained and all the problems that I went through should teach you everything that you need to know about the properties of limits. If you learned something from this video, or if you enjoyed it, please consider liking or subscribing.